In this video, I'll talk about motion under gravity. The motion of objects in space is generally influenced by the action of Earth's gravity and air resistance, and sometimes buoyancy force when the object falls through a liquid. If the air resistance and the buoyancy force are neglected, the object will tend to have an accelerated motion when they fall from a given height, or they will have a decelerated motion when they are projected upwards into the air. Recall that the equations of motions are v equals to u plus at, then h is equal to ut plus half at squared, and then v squared is equal to u squared plus 2ah or 2ax, as the case may be, where v is the velocity. You can check how I derived this equation in the video suggested up here. Alright, notice that if an object is under the influence of gravity, the acceleration can either be the acceleration is due to gravity, and it can either be positive or negative depending on whether it is being thrown upwards or it is being released to fall downwards. So the equations of motion for a body under the influence of gravity will become v is equal to u plus or minus gt, then h is equal to ut plus or minus half gt squared, then v squared is equal to u squared plus or minus 2gh. That means we have two cases: the case where the object is moving upwards, that is when the gravity will be negative, and the case where the object is moving downwards, that's where the gravity will be positive. Now let's consider a case where an object falls vertically downwards. Objects that fall freely have accelerated motion because of the action of the Earth's gravity on them. For instance, if a piece of stone is held by a boy on this high-rise building at height h, okay, if that boy releases the stone at the height h, it tends to fall from that height more and more faster until it hits the ground. It has also been observed that objects, no matter their difference in mass, they will fall under gravity with the same acceleration and the same time if the air resistance and the buoyancy force are neglected. The buoyancy force is considered when an object falls through a liquid. So if you neglect air resistance, every object will fall at the same acceleration. The initial velocity of the stone at the boy's hand, if the initial velocity represented by u, the initial velocity at the boy's hand is equal to 0, and the height of thrown, the height at which the object is expected to travel, is h. Okay, notice that the object is also falling. It will be accelerated due to gravity, so that is plus g. We can find the final velocity of this object. To find the final velocity of this object, remember that v is equal to u plus or minus gt. So in this case of an object being released from a particular height, or from an object being dropped, so when an object is dropped or when an object is released from a particular height, okay, notice that their final velocity will be 0 plus gt. Since the initial velocity will be 0, it means that it has probably been held by someone. Or for instance, when an apple falls off from a tree, if it falls off, that means it used to be stationary by the tree and then it falls due to gravity. As a result, v is equal to gt. The final velocity of that object is equal to gt. Notice that if the height is not given, we may also find the height at which the object will travel. Since height is equal to ut plus or minus half gt squared, since u is equal to 0, then h will be equal to half gt squared. The only parameter you need to note is this, that whenever an object is dropped from a height, or whenever an object is released from a height, its initial velocity will be zero. So the height of thrown, the height at which the object will travel, is given as this. Alright, so the implication is that if we make t the subject of the formula, we'll be able to find the time at which the object will travel. So that from this formula we can cross multiply, so that we'll have 2h to be equal to gt squared. So divide both sides by g, divide both sides by g, then t squared will be equal to 2h upon g. Notice that we can find the square root of both sides, so that t is the square root of 2h upon g. Now this is the time, this is the time taken by the ball to fall through this height h. We may also find the final velocity of this object. If the time is not known, we may also find the final velocity of this object from equation 3. Recall that equation 3 is v square equals to u square plus 2gh, where u is equal to 0 for a body falling freely under gravity, or a body that is dropped or released. Then v squared will be equal to 2gh, since u is equals to 0 from this formula, so that v is the square root of 2gh. Alright, let us consider a case where an object is thrown vertically upwards. Okay, let's say this is the boy, and then if this boy throws a stone vertically upwards in this manner at a particular initial velocity, let's say u, notice that this initial velocity will be decreasing, until it gets to a particular height called the maximum height. So let's say this is the maximum height h max. At that h max, the final velocity at that point is equal to 0. Why? Because the initial velocity at which the object is thrown would have decreased up to a point where it will be exhausted, and as a result the object will pause, the object will stop at that point. That point is the maximum height where the object can no longer move forward. Okay, and the reason for the decrease in velocity is because the object is moving against the influence of gravity, so the acceleration is decreased. As a result, the object falls backward. Okay, now the equations of motion for such motion is v equals to u minus gt, because it's actually moving upward, so acceleration is the negative. Okay, and then h is equals to ut minus half gt squared. Also v squared is equal to u squared minus 2gs. Now notice that for an object that is thrown vertically upwards, it should be known that its final velocity will be 0. Okay, so that we can say 0, we can find the initial velocity given the time, so that in this case 0 will be equal to gt, so that u is also equal to gt. Okay, also we can find, since v is equal to 0, we can find the distance of travel of the object, or we can find the h max. In this case our s will become the h max, because at h max the final velocity of the object is 0. So 0 squared equals to u squared minus 2g. Instead of s, we will have h max, because at h max v is equal to 0. So for us to have substituted v to be 0, the s, the distance traveled, is at h max. So we can find the maximum height, then we can take this to the other side of the equation to have 2g h max to be equal to u squared, so that h max is equal to u squared upon 2g. So this is the formula to find the maximum height of an object that is thrown vertically upwards. A golf ball is released from rest at the top of a very tall building. Neglecting air resistance, calculate the position and the velocity of the ball after 6 seconds. Now let's say this is the tall building and then this is the ground. Okay, this is the boy that will release the ball. Now if you release the golf ball, it means that the initial velocity of the ball had been 0. So the initial velocity of that ball is equal to 0. The boy is actually holding the ball. Now if he releases the ball, then we want to find the ball falls off to the ground with an acceleration of positive g, because it is falling due to gravity. Gravity we accelerate the motion. Okay, now to find the position of the object and the velocity after time t, which is 6 seconds. So we know the initial velocity of the object, we know the time, and then we know the acceleration. Now how do we find the position? We may use the second equation of motion, which is v squared equals to u squared plus 2gs. Okay, but since we don't know the final velocity, we may not be able to use that, but we may use s equal to ut plus half gt squared. We know the value of t and then we know g. We may find the position. Notice that the position is the distance. Okay, now so the position, which is s, is equal to u which is 0, and then t, which is equal to 6, plus half g, which is let's say g is 9.8 or 10. Let's use 10. G is a constant, which is equal to 10 meter per second squared, or 9.8 meter per second. Then the time, which is 6 squared. Alright, so that we'll have half multiplied by 5, then 36, 90 meters. So the position of that object is 90 meters away from the top of the high-rise building. Now let's say we want to find the velocity. Recall that velocity is equals to u plus gt. Okay, so v is equal to g, which is 10, and then the time of the object, which is 6 seconds, so that it becomes 60 meter per second. Now a billiard ball is thrown upwards from the top of a building with an initial velocity of this. Calculate the time taken to reach the maximum height. B, the maximum height reached by the ball. C, the velocity just before reaching the top of the building. And then D, the time taken. Now let's say this is the building. Okay, throws a billiard ball vertically upwards from the top of a building with an initial velocity of 20 meter per second. Okay, now we want to find the time to reach the maximum height. Let's say this is the maximum height. This is the top of the building. So we can find the maximum height. Don't forget that at the maximum height, the final velocity of the object will be 0. Okay, so we can make use of the equation of motion with height, with initial velocity, and with velocity, with the final velocity, and that will be equals to u squared. Since the object moves against gravity, the acceleration due to gravity will be minus g, minus 2gs. Okay, v, u, and h. Notice that when v equals to 0, then s will be the h max. Okay, so that we can say 0 squared equals to u squared, which is 20 squared, minus 2g, which is 10, then the h max now. So that 0 is equal to 400 minus 20 h max. If I take this to the other side of the equation, that will be 20 h max, which is equal to 400. So that h max is equal to 400 divided by 20, and that's of course equal to 220 meters. All right, so the maximum height is equal to 20 meters. Okay. Oh, that is the maximum height. We can also find the time taken to reach the maximum height. Notice that to find the time that it will take to reach the maximum height, remember that v is equals to u minus gt. So at for a body thrown vertically upward, v equal to 0, so 0 equals to u minus gt. So it implies that u is equal to gt. So we can find t simply by dividing both sides by g. If I divide both sides by g, then t will be equal to u upon g, where u is the 20 meter per second, that's the initial velocity, and g is 10. So the time taken is 2 seconds to reach the maximum height. Notice that the time it takes to reach the maximum height is the time it will take to fall to the ground. Now calculate the velocity just before reaching the top of the building. Notice that the top of the building is this point. Okay, so we want to find the velocity just before reaching the ground. That's the final velocity. Notice that as this object is thrown vertically upwards, this velocity with this 20 meter per second will be decreasing because the object is moving against gravity, and that's why it has negative acceleration here. So the object will be decreasing. It will get to a point where it would have exhausted its velocity, and that's why its final velocity is equal to 0. Notice that at that point the object will stop a bit. Okay, now after some time gravity will act on it, then it falls back to the ground. It falls back to the ground, to the top of the building. Now if it falls to the top of the building, it is falling with an initial velocity of 0, which is this. The final velocity of when it is being thrown up now becomes its initial velocity. Now this initial velocity will be accelerated downwards, so its acceleration here is positive g. So it will have a final velocity. Okay, now to find this final velocity, we can make use of v, which is equals to u plus gt. Notice that the time it takes to reach this point, to reach the maximum height, is the same time it will take to fall back to the top of the building. So the initial velocity is actually 0 plus g, which is 10, multiplied by the time, which is 2. So the velocity just before reaching the ground is equal to 20 meter per second. We may also use another formula, which is v squared equals to u squared plus 2gs, where s is the maximum height in this case, so we can just make use of h. And don't forget that u is 0, so that v squared is equal to 2gh. In this case, the v is the square root of 2g and h. So if you multiply 2gh, the maximum height is 20, so that is 2 times 10 multiplied by 20, which is equals to 400. So v is the square root of 400. Don't forget that the square root of 400 is 20, so that's 20 meter per second. Now to find the total time taken, notice that the total time taken is given by the time spent to get, is given by the sum of the time it takes to get to the maximum height and the time it takes to return to the point of throw, that is the top of the building. Let's say it takes t1 to get to the maximum height and it takes t2 to return from the maximum height. So the total time taken is t1 plus t2. Notice that the time it takes to reach the maximum height is also the time it takes to fall back to the ground. So it is t1 plus t2, then that is equals to 4 seconds. But you may also find it, we can also find it Okay, we have already found that t1 is 2 seconds. Okay, from question A. So we can also find t2 from the falling object, the falling motion. Now the formula with that is, I think we can use v equals to u plus gt, where v is the velocity just before reaching the ground, and we arrived at 20. We got v to be 20, and then u is 0, then g which is 10, the time in this case. So that's 20 equals to 10t. So it means that we can divide both sides by 10 in order to obtain t. So 10 cancels 10. Okay, so that t is equal to 20 upon 10, and t2 is equals to 2 seconds. So the total time taken is t1 plus t2, which is 2 plus 2, and that's equal to 4 seconds. So that is it. You need to know the scenario, what will happen to an object when it is moving upwards and when it is returning to the ground. So in summary, when an object is thrown vertically upwards, its initial velocity decreases, and when it gets to the maximum height, its initial velocity becomes 0. That means its final velocity is 0. So when it falls backward, that final velocity becomes the new initial velocity, and then it arrived at a final velocity v. A rocket moves upward starting from rest with an acceleration of 29.4 meter per second squared for 4 seconds. It runs out of fuel at the end of these 4 seconds and continues to move upward for a while before it returns and crashes on the ground. How high does it rise above its original starting point, where g is equal to 9.8 meter per second squared? Okay, now let's have something of this nature. A rocket moves straight upward, so we have, this is the rocket, okay, moving straight upward, and is actually starting from rest. If an object starts from rest, it means its initial velocity is equal to 0. Okay, and with an acceleration of this, that means this movement is actually with an acceleration. The acceleration at which it moves upward is 29.4 meter per second squared. Okay, that means we can actually find the final velocity of this object. Okay, for 4 seconds, that means it covered that distance for 4 seconds. For 4 seconds. Okay, now it runs out of fuel at this point and continues to move. It continues to move upward before it, let's say it moved from this point to this point, before it returns to the ground and crashes. Okay, now how high does it rise above its original starting point? Now to find how high it rises above its starting point, then we need to find this distance. Okay, and this distance, that will be, let's say this is be s1, then this has to be s2. All right, so to find s1, we need to find s1, and then we find s2, and we'll be done. In order to find s1, we have these parameters for the first displacement, for the first movement. Okay, now in order to find s1, s equal to ut plus half at squared. Notice that this motion is under gravity, so the equation becomes s equal to ut plus or minus half gt squared. But notice that the object moves upwards at its own acceleration, which is plus 29.4 meter per second. So we don't need to use this formula. We don't need to use it, so we'll go with this formula because the object has its own acceleration. So s is equal to ut, the u in this case is 0, and then the time is 4 seconds, then plus half, then the a in this case is 29.4 meter per second, and then the time is 4 squared, that's 16. So that s is equal to 2, we divide 16 to be 8, that's 8 multiplied by 29.4, and that's supposed to be equal to Okay, that's supposed to be equal to 235.2 meters. So 235.2 meter is the S1, the distance covered at the first instance. Now in order to find S2, we need to we do not know any parameters from this point, but of course we know that this object will have a final velocity of 0. Why? Because when the object gets to that point, it crashes and falls to the ground. So the object will have to stop a bit, then fall to the ground. That's the maximum height of the object. And also, we should know that this object, the final velocity when it runs out of fuel, will become its initial velocity at this point. Okay, so we need to find the final velocity on this point, the final velocity at this point. We need to find it because that is what will become the initial velocity at this point. All right, let's find the final velocity for the first instance. It has the zero velocity, the zero initial velocity has been increasing up to this point, so we have a final velocity. But because it runs out of fuel, this acceleration is due to the engine, it's not due to the gravity, it's due to the engine of the rocket. So because it runs out of fuel, then it begins to move, and the next movement is now due to gravity. So in this case we are going to consider gravity a lot, and it has to be negative gravity. So the object is no more moving at this acceleration, it's now moving due to gravity, and the initial velocity of that object is the final velocity when it has fuel in it. Okay, so let's find the final velocity when it has fuel inside. Okay, that will be v equals to u plus at. And of course, still for this scenario, and of course u is 0 and a is 29.4 multiplied by t, which is 4. As a result, the final velocity, which is 29.4 multiplied by 4, okay, that's equal to 117.6. So 117.6 is the initial velocity. 117.6 is also the final velocity when it has a fuel, and is the initial velocity, because as the object stops with that velocity, the fuel stops in the rocket with the velocity of 117.6. So it will pick up from the 117.6 up to where it would have exhausted its velocity, where the v will now be equal to 0. So we should not have question mark again. We should have, okay, let's have the question mark. Then we should have v will now be equal to 117.6 meter per second. Now let's find the distance s2. Since we now know that it will move at this initial velocity, it will have a final velocity of 0, and the acceleration in this case will be due to negative gravity. Okay, now because it's the engine is not at work again, no more petrol, so it needs to move due to gravity, and it's negative because it's moving upwards. So in this case we can make use of s, which is equal to ut plus or minus, but in this case we'll have minus half gt squared. So the u in this case is 1 Oh, we can make use of v squared equals to u squared plus 2as. Okay, yes we can. So, and I think that will be better. So if we make use of v squared equal to u squared minus 2gs, v squared in this case is 0, and of course u squared is equal to 2gs. Okay, how did I do that? Let me explain. Since v squared becomes 0, so we'll have 0 squared equal to u squared minus 2gs. If you take minus 2gs to the other side of the equation, if you take it to this place, then it will become positive. It will become 2gs equal to u squared. So it's the same thing as u squared equal to 2gs. As a result, s is equal to u squared upon 2g. Then the u squared in this case, that is 117.6 117.6 squared. So 117, so we get to have, let me get rid of this space. So the S is equal to 117.6 squared upon 2g, that's 9.8. So that's 117.6, okay, squared is then divided by 2 into 9.8, so that we'll have 705.6. 705.6, then, which is of course the S2 and is in meters. So the total distance, how high it rises above its starting point, is S1 plus S2. Recall that this is S1. So S1, which is 235.2 plus 705.6. So okay, 235.2 plus 705.6, which is equal to 940.8. 940.8 meters. So that's the distance covered.